This is a pre-calculus question about headings. I originally worked this with a student earlier in the day that I'm making this video, and I had the student convert from heading coordinates, heading angles, to Cartesian coordinate angles. No need to do that because the question starts, it gives headings, and it wants the heading. It doesn't want the Cartesian coordinate angle, so there's no need to convert. Convert what? Headings are clockwise from the positive y-axis, clockwise from north and otherwise. On the Cartesian plane, it is counterclockwise from the x-axis, from 0 degrees or 360, 0 degrees, and then clockwise. So that's why there's a conversion. But there's no need to convert because it's headings and it ends in headings, so I'm not going to convert. What I'm going to do is find the x component and the y component of each one of these trips, and I'm going to find the x component by doing d sine of theta, and the y component d cosine theta. And then I will add those two things together, and that will give the whole thing. So let's say the first part of the trip looks like that. That's the vector. And the second part of the trip, I'll do it in blue. Is that blue or purple? I don't know. Second part of the trip as a vector looks like that. Well, I'd add them together and get the final vector, which is, you go tail of the second to the arrow of the first, and you get the vector. And then I'm going to multiply the x and y of that vector by -1 because I want the return. So I'm going to multiply it by -1 and then find that angle. So for the first part of the trip, what is this? I won't even say first part. I'll say this is Franklin to Centerville. It's going to be A10, that's the distance. That's what D stands for. Sine of 165 degrees. No need to convert from heading degrees to coordinate plane degrees or unit circle degrees. And then I'm going to do A10 cosine 165 degrees. Always write that degree sign. So then when you go to enter it on the calculator, you remember, I have to be in degree mode. Then the next trip from Centerville to Rosemont is going to be 648 sine 32 degrees and 648 cosine 32 degrees. Now maybe you're a genius and you can do all this in your head. I'm going to use a calculator and I'm going to use Desmos. So I want to do 810 sine of 165 degrees. Am I in degree mode? Oh, yes, I am. And then I'm going to do 810 cosine 165 degrees. And that's it. That vector is 209, approximately 209.643, blah, 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 and -782. So it looks something like this. I'm just doing 500 1,000. So it's very 209 and -782, something like that. So that's the original trip. Something like that. I mean, that's way estimated. And then the next one is 648 sine 32 degrees. I'm still in degree mode. And 648 cosine 32 degrees. So it's 343, 549. It looks like this. Let's see, that's 500, 343, and then this is way estimated, 549, something like that. And then I will add that, and I end up somewhere like that. So here's the return vector when I add those together and then multiply each one by -1. That will be the return vector. And I'll get this angle by dividing the x by the y and taking the arctangent, because that will divide x by y. It's the arctangent of that because x is opposite and y is adjacent. Opposite over adjacent is tangent, but I want to find the angle whose arctangent is whatever those numbers are. So let me add these together. I'm just going to do it on Desmos. You could round these numbers and then add them together and get an approximate answer. I want to get as exact as possible. So I'm going to do this plus this. I'm going to add the x components, and that comes out to 553. So for the return trip, it's going to be -553. and I might as well do that. I'll put a negative in front of it because I want the return trip. And then I'm going to add the y's to get the y vector, y component of the vector. And then I want the negative of that. Because it's the return trip, I want the negative up here. So this is negative 553 and negative 553x and 232y. So I'm here at my destination, and I've got kind of a new coordinate plane, and I go negative 553 and up approximately 232, and that will get me back up 232, 553 to the left, and that gets me back to the destination. So now I want to take the arctangent of that whole thing so that I can find the angle, because that's what it wants, the angle. So I take that and I put it on top, and then divide, and I put this on the bottom, and I want to make sure those signs, there should be two negative signs in there. Yes, and so I want to, just to be accurate, I want this negative sign to be up here, and I get negative 67.165 and change, whatever it is. So now I have to say, what is that angle in heading? Well, heading is always positive, 0 to 360. So negative 65 would be 65 degrees and change whatever those decimal points are from the 360, because I go all the way around, and then negative 65 is the opposite direction. So 65 like that. So I just have to do 360 minus 65, or 65, it's 67, not 65. 360 minus 67, or 360 plus negative 67. So I'm just going to add 360 to this. So approximately 292.83 degrees, which is, again, taken clockwise, whatever that is, 292. So it's that direction. I don't know how, well, the size of it is going to be 553x and negative 553x and 232y. But that's the angle, 292.83 degrees. No reason to convert from headings to Cartesian angles or unit circle angles.